Okay, today we're going to look at the section 5.3, gravitational potential energy. Gravitational potential energy is energy that is stored due to the gravitational attraction to the Earth. So the potential energy, or we're going to symbolize as PE. Some books use U sub G, so you may see either one. And it's stored energy due to its position relative to some other object. Often that reference point is taken as the ground. But it does not have to be. It could be reference to the ceiling or any other place that you want. The gravitational potential depends on the mass of the object and the relative height from that point. And it's again assumed that the acceleration due to gravity is constant in free fall. In other words, that there's no air resistance as we've typically taken. All right, so let's see how we find this. So it's based on the mass, it's based on gravity, and it's based on height. So from that, we can put together a formula that would relate those two. So if we hop over to the other slide. So formulas. Remember that work is force times distance, and now we're going to take a look at what potential energy is. So potential energy, again, work. If you do work on something, it will change its potential energy. So the potential energy is equal to mass times gravity. And if you remember, mass times gravity is a force times a height, h, or d. So we're going to use potential energy then really as mgh, where mass, m is mass. That needs to be, again, in our base unit of kilograms. Gravity is 9.8 here on Earth, again, meters per second squared. And h is height, which is d, distance in the y direction. So that's our formula, that potential energy, or potential energy due to gravity in some books, is mgh. So we're going to hold on to that. Let's see if we can apply that now. So let's take a look at our first example. In our first example, we're looking for the potential energy in reference to the floor of a 3 kilogram book that rests on the edge of a table 1.5 meters above the floor. So if we do a quick sketch of what we've got, here's our table, and here's our book sitting on the edge of that table. That table is 1.5 meters. So our h is 1.5 meters. I'll get a decimal there. And this mass is 3 kilograms. It's kind of a heavy book. So we want to know what the potential energy is. The potential energy is simply mgh. So we have a mass of 3 kilograms. Gravity, acceleration 9.8 meters per second squared, and a height of 1.5 meters. So if we put that into our calculator and calculate that out, we see that we have 3 times 9.8 times 1.5, and that gives us 44.1 joules. So potential energy is 44.1 joules of energy. All right, that was pretty straightforward. So let's try another one. Erase that, hop over to another one, and again, as usual, I'm going to let you guys finish this one. So we have a stone that's held such that it has 20 joules of potential energy in reference to the water below. If the stone has a mass of 0.5 kilograms, how high, so we're looking for this height, above the water is the stone. So if we draw a little person holding this stone out, maybe he's on some sort of a bridge or whatever, and here's the water below. we're looking for this height. And we know, so we're given some information, that mass is 0.5 kilograms, that the potential energy of the stone is 20 joules, and we also know that gravity exists as 9.8 meters per second squared, and we are looking for the height. So see if you can work that through and come up with a solution.